Hello, I'm Barry Sullivan, Director of Program Development for the Electrical and Computer Engineering Department Heads Association. It is my pleasure to introduce John McLellan, Freescale University Programs North America, who will speak on Make It Awesome, Easy Embedded Education.
Hello, everyone. I like using the word awesome, so that was my title there. Today I'm going to talk to you about Freescale and some of our new technologies coming out. I know a lot of you heard recent presentations. I'm not going to beleaguer the point on most of industry wants to see people who can make things, people who can do things. And I'm going to echo a lot of that because I fully agree with most of that. But first, I kind of want to go through the corporate slides and talk a little bit about Freescale. We have a 50-year legacy. We've been around for a long, long time. We're a global leader in microcontrollers and digital networking processors. Over the past couple of years, we've really refined and focused our vision to be on microcontrollers and digital network processing, which I think is very important and has given us a lot of renewed focus and such. These are our core product groups, obviously, microcontrollers, digital networking, automotive, microcontrollers. Our primary markets, again, are automotive, networking, industrial, and consumer, and I'll kind of go into more details about those. Again, kind of echoing what we heard with the National Science Foundation's presentation and even with National Instruments before me. There are three trends that pretty much are consistent throughout all the industry speakers that you've heard today and will probably hear. The first one is going green. This is everything eco-friendly. We're now using microcontrollers and embedded systems solutions to make motors more efficient, to reduce emissions, to harvest energy from sources that we didn't think we could harvest from. The other one is health and safety. This is really big. Home automation, home medical monitoring. You saw the NSF guy also showed the pacemaker with cybersecurity and things like that. But also automotive safety with the new Google autonomous cars. I mean, safety in automobiles is critical. We have new radar systems coming on that'll stop the car if there's a passenger or if there's a pedestrian or a bicycle in the way. So there's a lot of really cool applications being developed on this. And then the third one is connected intelligence, and that's the Internet of Things pretty much, which hopefully all of you know about. Again, these are just some application examples. Networking is, base station, cellular, all that stuff. Automotive is driver assistance, that's kind of what I was talking about, powertrain, electrical vehicles, all that stuff. Industrial is everything, the connected intelligence. Industrial and consumer is connected intelligence. I want to talk about our portfolio because a lot of people don't realize how big Freescale's product portfolio is. So I just kind of want to take a few minutes to kind of educate you guys about some of our key technology. Freescale is a big proponent of the ARM architecture. We have several in our portfolio line. We have the Kinetis family, which is our M series. We actually have an M4. Freescale smartly decided to pass on the M3, and we went straight to the M4, which has the DSP functionality. And then on the low end, we have the M0 Plus. And that's a really cool processor that's really targeted to replace 8 16-bit microcontrollers. I'm going to skip the middle section and go down to the i.MX series. This is the ARM A series. You see a lot of this in e-readers, tablets, things of that nature, graphical human-machine interface type of devices. The i.MX application processors are not good or not great at real-time control. That's really where a microcontroller comes in. And so the middle section actually marries those two sides of the world into a hybrid solution. It's actually two cores. You have an A series core and you have an M series core. The M series core can run off and it can run motors, or it can do high-speed interrupts. It can react to things very fast. Whereas the A series is really great at presenting graphical images and interaction and touching and pinching and zooming and all that fun stuff that us humans like to do. Just kind of changing gears. So these are non-ARM architectures that we still have in-house. The Kariva, this is the old school automotive bread and butter that we do. We've been doing that for a long, long time. Extrinsic is our sensing solution. We have accelerometers, we have gyroscopes, we have, I forget all the other ones, a couple other sensors. And then Core IQ, this is the cellular base station market. So all the products in there fall into that camp. I want to talk now, change gears, about talk about our university programs. Very much like analog devices discussion earlier, and some of the other people. Why we do what we do, it's obviously because our customers will be using embedded applications. We are here to educate our technology talent pipeline is really why our motivation for doing this. We have 3 legs to our university program. The first one is recruitment. And I heard a question in some of the audiences yesterday, how many people are we hiring? I did a search this morning. There are 57 new hire positions available today. So if you want to go back and you have any graduating students, tell them to check us out. The second leg is research. This is actually run out of our R&D department. Again, on the panel session yesterday, and we run most of our research projects through the Semiconductor Research Corporation. Our research is focused on manufacturing processes, building better chips is kind of what our research focuses on. Applications research, building, new widgets and things typically runs through what would be our customers. So, Cisco's and such. The third piece, which is where I spend all my time, is the education piece. And this is really about, connecting with you guys, making solutions that are in the Freescale's portfolio easier to use and more available. So some of the resources we have for you and that we do. We have competitions. We sponsor some of the brand name competitions out there. We also have a few of our own. We do strategic partnerships. Yesterday in one of the panel sessions, we kind of hinted on this, but strategic partnerships are relationships, is really what this is. The better the relationship is between the company and the university, it's just mutually beneficial for everybody. So to answer kind of one of the questions that was posed yesterday, how do I get Freescale more engaged with my university? It's reach out to us. I mean, you kind of have to network with us. We have to have a good working relationship. We have to have that trust there. So regardless of that, if you are any academia, we have discounts on select tools. There's a public community. We have content, code, videos, pictures, Q&A. This is mainly targeting the students at the public level. A layer below that, we have a faculty portal, which is only open to faculty members. We keep the students out of here. This is where you can find textbooks, courseware, all the answer keys to all the questions that we post, things of that nature. And it's also the site to get direct contact with us. It's not always easy to find in a big company who you should talk to. So by going to the faculty portal, you can ask one of our university programs team directly and you will get an answer. So going to competitions, the two that we highlight is the Freescale Cup. I'm going to kind of just, this is a multifaceted competition, but at a very high level. It's a autonomous racing competition. It's the fastest around a track. The track is a black line, and it's about a 25 by 25 foot track. There's a lot of really interesting stuff coming out of this. Last year in China we had, let me refer to my notes. Last year in China we had 8,859 teams. And again, I kind of want to echo some things that were in the industry panel session. Overseas in Asia, these kids are very, very hungry. And that number shows it right there. In Europe, we have 70 teams, and a team is generally 3 or 4 students, by the way. India, 200, and in Mexico, we had 94 teams. In the US, this is our second year running it in the US. I have a West Coast and an East Coast one, and between the two, I have 50 teams. So new this year, we are actually launching a worldwide challenge. So we are going to take the winning team from each region, and we're going to bring them to China. And we're doing this for a couple of reasons. One, it's a pretty cool experience. But to the globalization point, we need our students to go over and see how things are. We need them to see how hungry these other kids are. We need them to see the motivation. And we also want them to get cultural exposure. China, I don't know how many of you have been over there. It's a good cultural experience to see it, and you need to, as a student, that's very, very valuable. I mean, it's infinitely valuable to get over there and understand that. So that's why we're doing that. The other one, and I'm supposed to talk a little bit about this, is EcoCar 2. I don't know how many of you are familiar with this, but EcoCar historically has been a very mechanical engineering, automotive engineering centric competition. So at the strong prodding by Freescale and General Motors, we are turning it into more of an ECE-based competition. So this year, actually, we had them totally re-engineer the center stack of the automobile that they are getting. So that is actually the new glass display that they're going to be using. It's got an i.MX, so they're going to be running a Linux-based system on there. They can control Pandora, they can log into Facebook, they can tweet while they're driving. I'm not saying any of this is smart, but they can do it. So we're going to see what the teams can do. The announcement I'm actually supposed to make is they are launching, they've already got funding for EcoCar 3. So again, the focus will be more on electrical and computer engineering. Obviously, we're going more into electric vehicles, various motor controls. So as I understand it, there's a pretty extensive interview process for universities done by the Department of Energy and the organizing committee. So if you are interested in this, you should reach out to Kristen De La Rosa, or you can go through me and I'll give you her contact information. There's a couple of universities I know that I've seen here. Virginia Tech has a very strong team, and if you're interested, you should talk to them. Mississippi State has a very strong team. I believe University of Waterloo has a team. There are a couple of universities that have teams, and you should talk to them about it to see their experiences from it, because I've heard only good things. So actually, before I go to the next slide, I want to talk to you about feedback. So I have a focus group coming up after this. Please come and attend it. I visit a lot of universities, and the three things I always hear is, one, it has to be cheap. Two, it has to be easy to use. And three, John, I really, really don't like Code Warrior. I don't know how many of you are familiar with that, but that's our programming tool. So I want to introduce our latest platform. These are the tools, the toys. This is called the Freedom platform. It has a Cortex M0 Plus. It's a 32-bit microcontroller. We have a 3-axis accelerometer on here. There's a little touchpad interface on one side, and then it's got an RGB LED on it. The pinouts, I don't know if you noticed, but it accepts Arduino shields. We decided instead of fighting it to go with it. And then the really cool unsung hero on this part is the new OpenSD connector. And really what this is it's the new debug connector kind of created by ARM, so that all the various vendors can come in with the IDEs and reprogram it. So you can put this thing as a mass storage device. You can program it with Kyle, you can program it with IAR, you can program it with Code Warrior, and latest as of the end of February, you can program it with Embed. And I'm not sure how many of you are familiar with that. So I'm going to talk about a little bit about Embed. It's very Arduino-ish in a way. The compiler's online, so all you have to do is log in, and you can start programming your C code. No need to install any executables, no drivers, none of that. You plug it in, you launch it, and you're good to go. It actually will download from the cloud into the board, and you're programming. It's a simplified C. So, for example, a lot of registers and all that is all gone. You would do something like PWM analog out on, and it'll start driving a motor. I mean, it's a very simplified form of C. So again, it's kind of just an upgrade path. From the beginner level, this is the ease of use, right? You guys want something easy that you can introduce students to. You can use the Embed software. You log in. There's lots of code already available. There's code for turning motors and servos and blinking lights and flashing lights. But then on the flip side, you can reconvert it into a more advanced, so you can start using some of the professional IDE tools that are out there, which are inherently valuable for the students to know. And again, I'm assuming all of you are familiar with Arduino and the shields. They're available everywhere. There are tons and tons of shields out there. Apparently even this kid will sell them to you. The other platform we have is the tower system, and just real quick, I'm going to kind of glaze over this one. This is more industrial strength type of stuff. I would recommend this for you know, a very focused capstone project or even a research kind of project, a grad student, this is going to be on the more high end. You can start to get some of the fancier processors and fancier high precision analog front ends and EKG. We have a pulse oximeter, lots of little different plugins for this board. Oh, you know what? I missed the key point on this guy. This board, so to all the other vendors out there, $13 for this new board. I also want to kind of shout out for some of the community boards out there. Some of the other feedback that I get a lot from faculty are, I want a dip. How many of you guys still want a dip package? There's always one. This is actually a board called Teensy 3.0. It's made by a guy, I don't know his name, his name's Paul. He got kickstarted. He got $30,000+ to build this board, which the new 3.0 uses our Kinetis M series device. So you can use this with Arduino, the IDE from what I understand, and it's also in a nice breadboard format. And then for all the Raspberry Pi guys out there and BeagleBone and some of the other ones out there, there's this latest one. It's wanboard.org. It actually runs our i.MX series. There's a dual core option available. Again, the single core is $79 and the dual is, it looks like $99. And I want to say on the website they offer an academic discount as well. So this one actually comes out of the box running Android Jelly Bean, which is really cool. You can also use Ubuntu, and then on the website it has a whole Linux kernel if you want to build it. So some reminders, the focus group, I like to hear y'all's feedback. I do a good job, or I try to do a good job of taking it and running with it. Stop by our expo booth. I will have a Freescale Cup kit available, and I'd be more than happy to tell you about it. I'm also going to have Freedom boards for the first 50 people that come and sign up. And then I'll actually have a WAN board on display too, if any of you want to see that one. Thank you.